can put it the I, imaginary. Okay, if you see the I, so we can look at the number of complex number. Okay, nanti later on we have another chapter is about the complex number. Okay, and for this one, how to find the x? So just the factorize plus 4. So we got it the -1 and 4. Okay, so D is a -1 and 4. Also same, D is a D, also same with the C. Okay, so we can call C equal to D. Okay, another example if you remember again about the power of the set, okay, power of the set, okay, trying to find the power of the set. Okay, we have a y, y, w, x and y, z. Ni one group, right? So can you find how many, can you find first power of set? Boleh tak? Okay, try dulu 2 minutes to find the power of the set. Betul tak ni? Is it true this one? So if before I give you, you must find the first item first, and the second item you won't forget, and we have a 3 item, right? So 3 item. So you must list down first for first item. This is the first item. First item. Okay, ni first item. And then you can collect 2 item. Okay, and make sure be careful about the bracket, yeah. You must put it, this is a 1 item. In YZ is a 1 item. You to do this one, you just put again the brackets. Okay, 2 item, and the last one, this is a 3 item. And don't forget to put the empty set here. And this is a power, so ada lagi satu bracket. This one and this one. Betul tak? Is it true?
Yes.
Okay, jangan lupa benda tu, bracket and bracket. Okay. So dia kata how many element in set A? Okay, you just kira je lah. Berapa elemen dia? 1, 2, 3. How many element? There are 3 element, right? Namely Y, X and YZ. Dia dah bagi tahu kat situ kan. Okay. Okay, satu lagi soalan. Another question is a power of A. We have a 2 power here. So how you want to got it? Okay, just follow the step lah. You can find the power of the set A first using the set A here. So this is a 1 item. We only 2 item here. So this is a 1 item and this is a 2 item. And then forget to write empty set and the bracket. This is a power, right? So the in the beginning of the bracket and last the bracket. Don't write down. Don't forget to write down the bracket. And first in the beginning and the last. Alright. So the answer again. Powers lagi kan. So you may know. You may write down 1 item, 2 item, 3 item, 4 item. So we have a 4 item here. So list down one item first. Okay, one, one. One. Nampak tak double bracket sini? Don't forget tulis tu ya. Ni. One item. Two item. Three item. Ni 4 item. One item, two item, three item, 4 item. And don't forget to write the empty set juga. Lepas tu dia ada bracket in the beginning and the last. Okay? Okay, so yang dekat sini the messy sikit dekat sini kan ada double bracket. We have a double bracket here. So make sure you must do it and you must write the double bracket every bracket if this is element. Kalaulah dia element. Okay? So saya pergi seterusnya. I move to another example. Okay, this is about the deductive reasoning. So don't forget to know about the law lah actually, okay? So prove that A subset B and B subset C, then you got it the A union B subset to C. So you can find the A subset B and B subset to C first. Okay? Using this one. So dia terjemahkanlah. Dia interpret to the logical words A and X and A C and A element of the B imply X element to C here. Okay? So using the implication law, okay, so you just put it the negation here. Okay. Because we want to find the A prime here, so tukar A prime daripada negation to A prime here, and then collect all the prime together. Okay. Okay, dia buka bracket, dia put the negation here kat luar guna De Morgan. And this one is a complement, negation taruh kat luar is outside from this formulas. And then you got it. This one. Okay. Okay, sebenarnya actually we want to do to put the negation and bracket to move from the intersection to the union. Baru dia jadi union dekat situ. Okay, ini contohlah example using the deductive reasoning with the law. Okay, ini another example here. Okay, ataupun awak boleh provekan kalau awak nak will be clear, you can draw it to the table ni, tunjuk macam ni kan satu-satu, you can do it lah. Okay. Ini some of the question. Okay, you can draw it, this one. Actually this one already given here and also for this one. Okay, I give you the last example ke-6. Okay, if you see your note juga also having the example 6. Okay, can we try do it for this example? Okay, 3 element of the one of this set. Is it true or not? Just you give me an answer, true or not. Betul ke tidak ni? Is it true the question A, 6A? Any question, any comment or any opinion from you? True or false?
True.
True, right? Because 3 is an element of the ni. 3 juga termasuk dekat sini kan? Include the this set. So this is the true. Okay, if you look at this one, A and B is the same, right? But 3 and we have a bracket and no bracket here. Okay, between A and B, which one the true and which one the false?
A is
B.
true.
B false.
Okay, B is a false because dia tak ada bracket pun kat sini kan. Don't have a bracket. Just you must write down 3 also. 3 sahaja. Only the 3. Not we have a bracket here. Okay? Okay. Okay, you look at C and D. C and D, okay? C and D is the same. Okay, which is we want to put the bracket or not bracket for this proper subset here. Which one the true? Okay, for the in term of the proper subset, you must put the bracket in this element. So this is a true, this is a not true. Okay, but for the element, you must see what the bracket have dalam ni ada apa. Kalau dia which is we have a bracket, so the element must be include the bracket. Contoh, I give you the example, another example here. Okay, I give you the example 3 and F. Okay, you look at this bracket is an element of this bracket. Okay, you look at this one. Must be put bracket or not for this one?
Yes, must be.
Okay, this is a true, right? Must be include the bracket because the element also include the bracket here. Okay, kena letak kat sini. Okay, for the subset, I think this is a wrong because we need to put the double bracket. Okay, faham tak beza antara subset and element dia?
Faham.
Okay, yeah. So must be careful lah if we have this question lah. Okay, so finish already for the chapter 2. So for today, also we can move to, we have have 1 hours again. So we can move the chapter 3 for today's. Okay, kita take a break dalam 3 minutes, okay?
Okay, Doctor.
Okay, don't forget to take the attendance, ya. Don't forget to take the attendance at the Putra Blast. Okay. Kita continue ya. Okay, so kita next chapter is chapter 3 is about the relation. Okay, so before we go further for the relation, I give you the problem statement for this relation. Okay, so how do we represent relationship between two related elements? Okay, which is if we have two elements, how we want to make the relationship between each other. So macam mana? How we want to do? Okay. For the maths in term of the maths field, so relation is connection between a set yang kita boleh panggil we can call this input and another one set of the output. So we have a two platform, input and output, and relationship to find to together is set input and output, we can call relation. Connection dia antara dia input and input, we can call relation. Contohnya macam ni lah, this is input, this is a output. So macam mana, how we want to do the relationship between input and output? So we connected with the relation. Okay. So for today, for this chapter, kita akan go further for the relation, binary relation and equivalent classes. Okay, in the chapter 3 ni, we can finish for this week lah. For today's, kita akan masuk by relation and binary relation. And on the Wednesday, we can finish the chapter 3 with the equivalent classes. So this week kita akan habiskan, we can finish all the chapter 3 and the next week we go further for the chapter 4. Okay. The learning outcome for the lecture 11 ataupun first for the relation first 3.1, dalam 3.1 ni, first we find the Cartesian product. Apa itu? We can define the Cartesian product and then we can define the relation and we can obtain the domain and the range. Okay. Apa itu? What is a Cartesian product or product set? Okay, sama juga. We have a two set. We can call G and H. Okay, G and H. Okay, we can say the Cartesian product of G and H we can denote and we can return as a G, ada pangkah macam tu kan? Is nak cakap pangkah ke multiply ke I don't know. Tapi kita panggil dia Cartesian product here. Okay, kalau awak say know about see the symbol, the pangkah macam ni ataupun this multiply, so we can say this is a Cartesian product of G and H. Okay, which is all the order pair we have a G and H. Where the G ni, element of the G ni is an element of the G, capital G, and H is a element of the H. Okay. So we can return as a pairing macam ni lah, GH. Okay, the Cartesian product of G and H, we can write down with the pairing G and H, which is G ni element of the G, capital G, and H ni is element of the capital H. Okay, macam mana kita nak dapat? Kita tengok sini ya. I give belum lagi example. Okay, Cartesian product of A and B ataupun we can use the other word A and B. Kita boleh buat A Cartesian, the Cartesian product of the set A and B consists the all of the pair whose first element in A. Yang first element ni adalah elemen dalam A kalau kita buat pairing macam ni kan. And the second element ni dalam B. Okay. Contoh ya, I give you the example. Okay, can you find the A Cartesian B? Okay, we have a set A. This is a set A. This is a set B. Set A is a B. Set B is a 1, 2, 3. So to find the A Cartesian B, A Cartesian B, so meaning cara dia okay, so you can see first the set A. Sebab dia yang depan, dia yang paling depan kan. Yang paling depan we can look at the set A. Okay, so you look at the element of the set A and B. So A, nampak tak ni? Okay. So you look at this one. A1, A2, A3. Okay. So the second element of the set A iaitu which is a B. So B1, B2 and B3. Look at this. Okay. So ini adalah this is A Cartesian B. Okay. If we want to the B Cartesian B, which is okay, kita kena buat satu lagi B lah macam ni. 1, 2, 3. Okay, so you look at the first element, the first set, B. So 1 go to 1, 1 go to 2, 1 go to 3. So we got it 1, 1, 1, 2, 1, 3. Okay, the second element of the set B is a 1 and 2, 1, 2, 2, 2, 3. So nampak tak ni? 2, 1, 2, 2 and 2, 3. And the third element of the set B is a 3, 1, 3, 2 and 3, 3. Okay, so the main point here, so you must look at first the set apa yang pertama tu, the first set. Ada nak tanya tak? Any question?
No.
No?
No, doctor.
Jing Jeng? Any question? Jing Jeng, are you hear me? Okay. No question, okay? I hope you understand. Okay, so okay, kita look at the remark kat situ. Okay, remark. The Cartesian product G Cartesian G Cartesian H and H Cartesian are not equal unless G is a empty set and H also the empty set, which is G Cartesian C must be an empty set, or we can say this is a G Cartesian S. Okay, meaning that okay, kalau awak nak buat to find the G Cartesian H, awak kena dapatkan elemen dia. Actually another question, you can find the S Cartesian G. You jangan cakap D is a same. It's not same. Okay, D is a not same. You must find G Cartesian and S, another one, and S Cartesian H. G is other answer. Ni answer yang lain, ni answer yang lain. Kecuali except unless G ni is a empty set and H empty set, baru we can call G is equal the H. Faham? Kalau dia ni dia tak sama ya. Even the position is chain is not equal. So you can find both this one. Contoh, kalau saya nak bagi contoh ya. I give you example here. Okay, find the product G. D is a G, D is a H. Okay, so and find the G Charterson H. Okay, so ini okay, so you can see the first set. This is a G. So 1 to H, 1 to I, 1 to J. Nampak tak? You look at this one. 1H, 1J, 1I, and 1J. And then the second element is a 2I, 2H, 2I, and 2J. 2H, 2I, 2J. Okay, try to find the H Charterson G. Sama tak? Is it same with the G Charterson H? Sama kan? Nampak tak? It's not same, the element dia. Okay, so the H product of the H Charterson G is not equal to Charterson product G Charterson H. Okay, tak sama. So it's not. Okay. So we can conclude this one is a G.
Betul.
Kan, yang ini lain. This is different from this one. Okay, kalaulah if we, let's say we have a product of the set of the, we can do the product with the insert. So we can return as a H Charterson H. Okay, atau or we can write down. Okay, write down as the H square. Okay, also for the, so the product of the real set insert we can denoted by the real numbers R square. Okay. Okay, relation. Okay, relation and set of the input and output. I already informed you before, input and output. And kita boleh, we can return as a order ataupun pairing with the input, the first element, and output, the second element here. So you just bracket here, input and output. Okay, so the relationship, the relation of the input and output, we can represent this, and whether we can use represent as the mapping diagram, or we can do we can make a graph here. Okay, awak nak guna mapping diagram can, and we can draw a graph also can. Okay, contoh ya, I give you the example. R represent as order pair. Okay, if you look at or you can see the pairing or this one. So you can make sure this is a relation lah. So R 0, -2, 0, 1, 1, 2, 2, 1, 3, 4. So you can declare this. The first item is the input and the second item is the output for this pairing. Okay, and you can represent it as a mapping diagram to show this is a pairing. Okay, contohnya I give you example mapping diagram relation. Okay, you look at this one. This is a input, this is a output, and then relationship to connecting between the input and output we can use for the R, or this is a relation. Okay, so you look at this one. This is a 0, -2, 0, 1. Okay. Another one is a 1, 1, 2, 2, 1, 3, 4. Okay, sama kan? Is same this one. This is a mapping diagram. Okay, line this one line is a connects between the input and their output. Okay, this one is a input. This one is a output. Okay. Okay. Selain tu, you can draw it using or you can representing as the graph. So if you have this pairing 0, -2 here, 0, -2. This one is a 2, 1. This one is a 1, 1, 1, 2. Sorry. This one is a 0, 1. This one is a 3, 4. So you can illustrate through the graph. Okay. Okay, actually we have a domain and range. Domain, what is domain? Domain is a set of the all input. So all input and we can denote it ataupun kita boleh panggil we can call the domain is a DR. Okay, contoh I give you the example 01 yang 01 this is a pairing 0, 1, 2, 1, 3 and 4C. So to find the domain, so we can written as D, capital D, domain of the relation R. So X member of the real numbers, which is X2 what? The input X is a 0, 1. Okay, kalau ada we have a 1, 1, so just write down 1 only and write down one time only. Okay, sekali sahaja, no need to 1, 1, no need. Just write down as 1. Okay, 0, 1, 4. Okay. Okay, for the okay, refer the other example, refer the following mapping diagram in this relation R. So you can find this one. If you look at from the mapping diagram, so you can find the domain from diagram through the set A. This is a -2, 3 and 4, 10. So this is a input. Okay, so if we have a graph, example in graph, so you can find also for to find the domain. Okay, look at this one. So the domain in the actually for this graph, domain is in the axis X. So axis X beginning from the 2 here. Okay, so X is dia dekat left hand side, so which is X is less than and equal to 2. Okay, okay. After we know about the range, the domain, so make sure you must know lah dia must know about the range. Range or we can call is a image of the relation. So this show about the all the output of the R, all the output of the R, and we can denote it as the I, capital I. I actually is a image, okay? Image of the real. So to find the to find the range of this relation is the pairing the second element. So 1, 2, 3 and 6. So the image of the relation is a 1, 2, 3 and 6 here. Okay, any question? Ada nak tanya tak? Okay, faham ya? Okay, another example. Okay, if I give you the mapping diagram. So if you want to find the range of the relation, so we can look at in the output from the input lah. Okay, the output from this diagram is a -1, 0, 2, 4 and 6. So this is a range for this problem. Okay, kalau yang ini example 11, so the range dia subject to the y axis. So from the y axis here. Kalau input must be from the x axis. Okay, so just review. And after we know about the relation, okay, relation is between two variables, x and y, and is used for the order pair lah. Dia represent with the order pair, okay, and consists the x and y coordinate. Okay, a relation maybe can view as a order pair. Kita boleh buat order pair, sama ada order pair maksudnya yang dalam bentuk in term this one, or we can represent as the mapping design, table also, equation, and we can return in sentence. Okay, x values. Okay, kalau we can say kalau in the pairing here, so selalunya x, we can say this is x values. Also we can namely this input domain. Also we can say this is a independent variable. Okay, and the y values we can namely is a output range dependent variable. Okay, contoh more example here. And what is the domain? Can you give me the answer?
0, 1, 2, 3, 4, 5.
Okay, good. 0, 1, 2, 3, 4, 5. So yang itu adalah that is a domain. Okay, range.
-5, -4, -3, -2, -1, 0.
Okay, good. So the domain is the y-axis iaitu -5, -4, -3, -2, -1 and 0. Okay. Okay, another example. Okay, the input is given here. So which is we can find the pairing each other. Okay, the domain dia must be from this one lah, and the input the range dia must be from this one. So we got it. The domain is 5, -5, 0, 9, and 1, and the range is -2 and 7. And the pairing there we can write down is 4, -2, and 5, -2, 0, -2, and 0, 7, 9, 7, -1 and 7. Okay, so this is a pairing. So yang belah sini yang the left hand side is 4, 5, 0, 0, 9 ni. 0, 0 we have a 2, so just put the 0 only. Okay, the other one is a -2 and -7 sahaja. Also we have a -2 and -7.
Apa subtitle?
Padam pula, tak apa. Okay, kita dah habis. Okay, for belum habis lagi. Sekejap. Okay.
Habis?
Dah habis Okay, dah habis yang
Habis
ni.
chapter 3.
Sekejap, saya tukar slide ya.
Kena print balik dah.
Okay. Satu lagi topik in lecture 12. Okay. Okay, actually what the application using the relation. Okay, relation are deal with everyday. We can use for the businesses and their telephone numbers, employees and their salaries pun boleh juga. Maksudnya we can say using the business and their telephone numbers, employees and their salaries. Dia ada term this one. Okay, using the pairing. Okay, relation are used to solve the problem, assist to determine which pair of the city are linked by a line flight in a network. We can finding a variable order for the different passes of the complicated project and so more lah, banyak sangat ya. More many for the using the application of the relation. Okay. Example of the relation, we can use the some of the symbol of the mathematics, real, equal, less than, and greater, and so on. Okay, on the power of the set R, we can use for the equal, subset, on subsets. Okay, I give you an example. Okay, if A is a set of the student, which is A is a set of the student and B is a set of the course. So we can use this one, A and B, use the pairing each other. Okay, we can consist with the pairing, which is the element of the set A is is a student and enroll in the course apa kan? We can say the course B. Okay, contoh, I give you a contoh. This relation is a pairing A and B. A is element of the A, B element of B. Okay, this pairing show represent about the student A enroll in the course B. Okay, example 2. Okay, A is a set of all the cities and B is a set of the 50 states in US. So, how we want to relate it? To do the related between the set A and set B. So using the pairing A and B belong to R if the city A in the state B. Okay, the solution. Contoh, I give you Boulder. Boulder is a cities and Colorado is a state in US. Okay, maksudnya cities borders dia punya state is US Colorado. Okay, so ini contoh dia lah. Red Band, D is a state, D is a city and the state dia is the New Jersey. Okay, example 3. Okay, we have a set A, 0, 1, 2 and B, A, B. So to find the relation for this one, so you can find 0, 0, A. You can use this one whether you want to using the mapping diagram. Okay, so this is an input 0, 1, 2 and this is an output A and B. So you can make the relationship between each other. So you can write down as the R, 0A, 0B, 1A, 1B, okay, 2B. Okay, 2B only. Sorry. 2B. So, relation dia 0A, B, 1A and 2B. So, R ni is a relation A to B. Okay, we have a pairing here. Okay, So it's about the pairing and chartesian of the product. So we go for the lecture 12. Learning outcome for this one, and we know about the binary relation, and the last one we can find the equivalent relation. Ini on the Wednesday, right? Okay. So kita pergi sikit about the binary relation. Okay, binary relation, or we can say simply of the relation R of from the set A into the set B is a subset of the A Cartesian B, or we can written as a R subset A Cartesian B. Okay, if the pair A B member of the R, we can return, kalau awak jumpa macam ni, A, B, element of the R, we can return A relation, ni ya, A and B. A, we can write as A relation B, atau we can say A has a relation R with the B. A has a relation R with the A. Kalau let's say is A has no relation with the B, so we can denote it as the slash for the R. Or we can denote it A, B is not element the R. B is the same. Okay, we can say as A has no element, no relation R with the B. Ataupun or you can return, kalau has a relation R, we can say A related to B by the R. Boleh juga. We can write down this one. Okay. Selain R, we can use for the symbol this one. We can say this is a tilde. Tilde. Okay, if we have a denoted A. Okay, before this, we know the A relation B. A has a relation with the B. Or we can write down A tilde B. Sama juga. A is related to B. Kita boleh write down here. Mana-manalah if you want to write. The symbol is same. Okay. Okay, this is a set A and B. So when we look at the A Cartesian B, so you look at this one. 0 A, 0 B, 1 A, 2 B. Okay. You look at 0A, this is a element of the R. 0B is a element the R, 1A is element the R, 1B tak ada kat sini kan. So this is a not element of the R. Also 2A is not element the R, but 2B is a element of R. Alright? So we can say ini, we can say 1 is not element, has no element on relation to B. Macam ni. Okay, ada nak tanya tak? Any question? No? Okay, kalau tak ada. Okay, if no, so we go for this. Okay, we look at this example. Okay, consider the following relation on the Z. Okay, so we have many of the relation R1 until R6. So every the pairing, if given with the condition, Okay, dia bagi R1 condition remain and follows A less than and equal to B, and also for this one lah. Okay, so dia kata which of this relation contain each of this pair. Dia bagi pairing dia, input and output. Is it this pairing is satisfied for the relation is given here. So I draw the table here. Okay, I put the element, the pairing 1 1, 1 2, 2 1, 1 negative, and 2 2 here. So I recognize on every the relation 1, relation 2 until relation 6. Okay, we look at one by one. Either each pair satisfied with the relation is given here. Okay, so you look at this one. Okay, for the 1 1 is satisfied. Is it satisfied with the relation 1 here? Satisfied tak? You look at the condition is given here. Okay, so if a 1 1, which is this is a 1, this is a 1, is a maksudnya means A and 1 less than and equal to 1. Is it true or not?
True.
True, right? Sebab dia sama
Yes.
dengan kan? Okay. Also for the 1 2 also. But for 2 1, okay, you look at it, 2 and 1. Dia tak lebih 2 is not is a less than and equal to 1. So this is a true completely is not true. Okay? Okay, so yang the pairing is satisfied with the relation 1 is a 1 1, 1 2 and 2 2 only. For the 2 1 and 1 negative 1 is a not satisfied with the condition in relation 1. Is it true?
No. Tak.
Okay, okay, we go to for relation 2, right? Relation 2. Okay, tengok satu-satu yang mana?
Unknown caller.
Relation 2.
Satisfied.
1 1. Not satisfied, right?
No.
1 2.
No.
No.
Yes. Yes.
Okay, yes, yes. So this one. Okay, so the other ones relation 3. So A equal to B, A negative B. So
No, no, yes.
yes, and only the 1 1,
And
Dengan-
1 negative 1.
1 negative 1. Is it true? 1 negative 1? I don't think so.
No.
And yeah, yes, yes, yes. Sorry. 1 negative 1. Okay. So put the in here. Okay, this one and this one, right? Okay. R4.
1 1 2 2.
1 1 2 2. Yes, this one is not. Is not. Is. Okay. Okay, R5.
1 2.
1 2. Okay, only the 1 2, right? And sorry, only the 2 1. 1 2. 1 2. 1 2 or 2 1?
2 1.
2 1, right? Okay, this one is no. Okay. Last one is A plus B is less than and equal to 3. So, ni banyak sikit lah. So, I think this one is a right. one is right. No, this one is no. Okay, is it true? Okay. So the solution, okay, saya ulang balik yang ni tadi tu. The solution will be, you can write down 1, 1. Okay, 1, 1 is a element of the R1, R3, R4 and R6. Nampak tak ni? So for the 1, 2, element only for the R1 and R6 only. And 2, 1, element of the R2, R5 and R6. And the last one, last one, 1, -1 is between the R2, R3 and R6. And the last one is a element of the R1, R3 and R4. Okay? Any question? Tak ada? So you can give the solution and the last answer and to show every the pairing tu the related with the which relation. Okay? Okay, before we finish, okay, satu lagi topik the important thing to determine equivalent relative. Okay? Ini saya pergi further juga. Okay. We go further ya. Okay, before we to determine equivalent relative, you must follow some of the actually we have three types you must certify. Okay, 3 type tu we have a reflexive, symmetric and transitive. Okay, apa benda tu kan? Reflexive. Okay. Let's say R is a binary relation on the set A. So we have a element of the set A, X, Y, Z. Okay, R2 we can call this is a reflexive if the X element A ni is a X relation relation with the R. Dirinya sendiri saja, in self, okay? Okay, and symmetric, if we have a X relation to Y, will be implies Y relation to X. And the transitive is about the X relation to Y, and we have another one, Y relation to X, and will be implies X to, ini Z ya, sorry, ini Z. X implies to Z. Relation to Z. Okay. Another alternative ways we can show using the tilde. Just put it the tilde here. Okay, X tilde X, Y tilde X. Kalau transitive will be X tilde Y and Y tilde Z, dia akan jadi implies the X tilde Z. Okay. Ini if we use the relation, ini if we use the tilde. Okay. Okay, a relation R is on the set A is called reflexive if the element of the AA is element of the R for every A element the A. Okay, and I give you the example. Okay, if we have a set 1, 2, 3, 4, so and here this example give the three relation R2, R3 and R4. So you can find it which of them are reflexive. Okay, whether the R2, R3 and R4. Okay, we can look at the one by one lah. Okay, one R2, is it the solution is R2 is reflexive or not? Macam mana nak tahu refleksif? Kalau refleksif, if you remember again, dia punya ni mestilah A to A, right? A to A. So which is this one is a 1 to 1. Dia ada 4 kan? So suppose 1 to 1 is a right. So you must write down again 2 2, 3 3 and 4 4, right? So ini tak cukup. It's not enough for the R2. Okay, so we can hold down for the R2 and go for the R3. R3, you look at, this is a 1 1. Okay, 2 2, 3 3 and 4 4. Okay, suppose we have a 4 element here, 1 2 3 4. So it's a complete for this relation, right? The R4 is we don't have a 1 1, 2 2 2 3 3 and 4 4. So tak ada semua kan? We don't have all the reflexive set here. So only the R3. The solution may be R3. Are you agree with me?
Okay.
Okay, yang lain? The others?
Yeah, agree.
Okay,
Agree.
so okay, if you don't understand, please let me know, okay? Okay, so the solution on R3. Okay, we can try another one. For this one. Okay, can you try to give me the question what the relation are reflexive? Okay, we have a R1 anti RC. Okay, so we can go one by one lah. Okay, okay, R1 1 1 2 2. Okay, let's say we have a 4 kan, until 4. So 3 3 we don't have 3 3 here. 4 4, so it's not complete. Okay, for the R2 1 1 2 2. Okay, so 3 3 tak ada, 4 4 tak ada, 5 5 tak ada. 5 5 pula. 4 4 don't have. So it's a not complete. Also R3 1 1 2 2 3 3 4 4. So this is a complete. This one 1 1 don't have, 2 2 don't have, 3 3 don't have, 4 4 don't have. So this is not complete. This is a wrong. So R5 is a 1 1, 2 2, 3 3 and 4 4. This is a complete. Also for the RC is not complete or wrong. So the solution for the reflexive is a R3 and R5. Others are not reflexive. Okay, any question? So I hope you understand, okay? Okay, kita pergi 945. Okay, 9:45. Okay, saya tak takut tersebut. Okay, kita pergi symmetric pula, okay? We go for the symmetrics, okay? The definition of the symmetry, relation R on the set A is called symmetry. If BAB, element of the AB, element of the AR, implies B to the A. Okay? So, can you find this relation is symmetry or not? Okay, for the R2. Okay, R2 which is actually we need to set here to set here, which is AB to BA. Okay, so this one is a 1 2 is a 2 1. Okay, so this is a okay. Okay, for the R3 is a 1 2, okay, 2 1. 1, 4, 4, 1. Lucu tu dia. Okay. Okay, this one is a 2, 1. Ada tak 1, 2? Tak ada kan? 1, 2 don't have. 3, 1.
Ada.
1, 3 tak ada. Okay, 3, 2, 2, 3, 2, 3 tak ada. 4, 1 is a 1, 4 don't have. 4, 2 is a 2, 4. Tak ada. 4, 3 is 3. Tak ada, semua tak ada ni. So, the solution will be R2 and R3 are symmetric.
Geram betul lah tak ada dalam lecture ni. Aku macam lah tak fokus langsung lah. Kenapa dia bagi dalam lecture dia kan tak boleh.
So, kita pergi kepada satu lagi sebelum habis. Relation.
Ni dia buat
transitive.
sendiri.
Okay.
Nanti mesti dah tercakap.
Transitive, so we have a B, B, C. So, we got it the A, C.
Tak sama doktor.
Okay, solution.
Tak kuat, nak tanya record pun tak record.
So, ini saya nak pergi minggu depan lah. Okay, so I want to be bukan minggu depan, on the Wednesday. So, secara as conclusion dia,